The sun is about to vanish for SEX months. Not in some distant future. This is already happening on Earth. Right now. And if you think Australian winter is cold, you have no idea how lucky you actually are. What's up, everyone? Before we dive into this mind-bending scenario, here's your friendly reminder. This is speculative content for entertainment and education. The real science is fascinating, but always do your own research if you want to dig deeper. The hidden reality behind our normal winter. So here we are, approaching the winter solstice on June 21st here in Australia, the shortest day of our year. Most of us think we understand winter, right? It gets a bit colder, days get shorter, we complain about leaving work in the dark. But what if I told you that our harsh Australian winter is actually Earth being incredibly merciful to us? See, there's this cosmic dance happening above our heads that most people never really grasp. Earth isn't just spinning around the sun like a perfectly upright top. No, our planet is tilted, wobbling through space at a 23.5-degree angle like a slightly drunk dancer who's still somehow keeping perfect time. And that tilt? That's literally the only thing standing between Sydney's winter and 6 months of total, bone-chilling darkness. The science that could change everything. According to NASA orbital mechanics data, Earth's axial tilt is what creates our seasons. When our hemisphere tilts away from the sun during winter, we get less direct sunlight, hence shorter days. But here's where it gets wild. That 23.5-degree tilt is actually pretty modest. Mars, for example, has an axial tilt of about 25 degrees, not much different from Earth. But here's the kicker. Mars' tilt can vary dramatically over hundreds of thousands of years, swinging anywhere from 15 to 35 degrees. When it hits those extreme tilts, the polar regions can experience seasons that last for months in complete darkness or blazing sunlight. So what would happen if Earth suddenly decided to copy Mars' more dramatic approach to seasons? Welcome to the nightmare scenario. Picture this, you're in Sydney, and it's the beginning of what we'd now call true winter. The sun rises on March 1st and then, it just keeps setting earlier and earlier. By April, you're getting maybe 4 hours of dim, slanted sunlight. By May, it's down to 2 hours of what barely qualifies as twilight. And then June arrives and the sun simply doesn't. For the next 6 months, Sydney exists in a twilight world. Not complete darkness. There'd still be stars, moon phases, maybe some aurora activity as Earth's magnetic field interacts more dramatically with solar wind, but no direct sunlight. None. The temperature would plummet, not just to our current winter lows of 8-10 degrees Celsius, but potentially down to Arctic levels, -20, -30, maybe even -40 degrees Celsius in the coldest regions. The cascade effect, when nature breaks down. Now, we actually have real-world data for what extended darkness does to ecosystems, thanks to polar research stations in Antarctica and the Arctic. According to studies published in the Journal of Polar Biology, extended darkness periods create what researchers call ecosystem hibernation. First, photosynthesis would essentially cease across the entire continent. Every green plant, every tree, every blade of grass would enter survival mode, drawing on stored energy reserves. The lucky ones, the ones with deep root systems and substantial energy storage, might last 3 or 4 months. The rest? They'd simply shut down and die. But here's where it gets really interesting. This isn't just about plants. The entire food web would. Think about it. No plants mean no insects. No insects mean no small birds. No small birds mean no larger predators. Within weeks, you'd see mass migrations the likes of which have never been recorded in human history. Every animal capable of movement would be fleeing north, toward the equator, toward any scrap of remaining sunlight. And humans? We'd be right there with them. Psychology of perpetual darkness. Here's something most people don't consider. We have actual research on what extended darkness does to human psychology. Studies from places like Utqiagvik, Alaska, where the sun doesn't rise for about 65 days each year, show dramatic increases in depression, anxiety, and what psychologists call seasonal affective disorder or SAD. But we're talking about 180 days of darkness. 6 months. The psychological research suggests that after about 90 days of minimal sunlight, human circadian rhythms essentially break down. Sleep cycles become erratic, vitamin D deficiency reaches critical levels, and immune systems start failing. The Inuit peoples of the far north have developed cultural and social structures over thousands of years to cope with extended darkness periods. But they've never had to deal with 6 months of it, and they've had generations to adapt. Modern urban populations like Sydney? We'd be completely unprepared. Could we actually survive? But here's a fascinating question. With our current technology, could humanity actually survive this scenario? And I mean really survive, not just scrape by for a few months before civilization collapses. The answer might surprise you. We already have the basic technologies: massive indoor farming operations using LED grow lights, geothermal heating systems, and advanced renewable energy storage. Countries like Iceland already heat entire cities using geothermal energy, and vertical farming operations in places like Japan produce crops year-round under artificial lighting. According to agricultural engineering studies, you could theoretically feed a population using LED-based hydroponics with about 95% less water and 80% less space than traditional farming. The energy requirements would be enormous, but not impossible, especially if you're drawing from geothermal, nuclear, or stored renewable sources. But here's the real challenge. Could you scale these technologies fast enough? Could you retrofit an entire continent's infrastructure in the few months of warning you'd have before the extended darkness hit? Why this might actually be impossible. Now, let's be honest about the other side of this scenario. Some climate scientists argue that the kind of extreme seasonal variation we're talking about would create feedback loops that make survival nearly impossible. Dr. Michael Mann's climate research suggests that extreme seasonal variations could trigger what's called a snowball Earth scenario. As more of the planet's surface becomes covered in ice and snow during the extended winter, more sunlight gets reflected back into space instead of being absorbed. This creates a cooling feedback loop that could push the planet into a permanent ice age state. There's also the atmospheric question. Extended periods without photosynthesis would mean atmospheric CO2 levels would continue rising from animal respiration and decomposition, while oxygen levels would gradually decrease. Some atmospheric scientists calculate that after about 4 months of minimal photosynthesis, we'd start seeing measurable changes in atmospheric composition. And then there's the simple economics of it. The energy requirements for keeping millions of people alive in artificial environments for 6 months of the year would be staggering. We're talking about energy consumption levels that would dwarf anything in human history. What we can learn. But here's what's fascinating about this thought experiment. It reveals both our incredible vulnerability and our remarkable adaptability as a species. The truth is, we already live on a planet with extreme seasonal variations. They're just not evenly distributed. The Arctic and Antarctic regions experience months of darkness and light, and life persists there. Not easily, not comfortably, but it persists. And our current climate change crisis is, in many ways, preparing us for exactly these kinds of extreme scenarios. The renewable energy infrastructure we're building, the advances in indoor agriculture, the research into sustainable living, all of this would be crucial for surviving an extreme seasonal planet. Maybe the real question isn't whether we could survive such a scenario, but whether we'd want to. What kind of society would emerge from 6 months of darkness followed by 6 months of blazing light? How would our cultures, our relationships, our entire way of understanding time and seasons change? Back to our mild winter. Which brings us back to our modest little winter solstice here in Australia. That shortest day on June 21st, when Sydney gets about 9 hours and 53 minutes of daylight, compared to the 14 hours and 25 minutes we get in summer. Suddenly that doesn't seem so bad, does it? That 23.5-degree tilt that we never think about is literally the difference between a manageable winter and a planet where half the year is spent in survival mode. Every winter sunrise you see, every afternoon shadow, every moment when you step outside and feel that winter sun on your face, that's Earth's tilt working in your favor. That's cosmic mechanics fine-tuned to make life not just possible, but comfortable. The bigger questions this raises. But this whole thought experiment raises some pretty profound questions, doesn't it? If our current winter seems harsh, how spoiled are we by our planet's relatively stable seasonal patterns? What does it say about human adaptability that we can imagine surviving even these extreme scenarios? And as we face climate change and potentially dramatic shifts in global weather patterns, are we mentally preparing ourselves for a world that might demand this kind of extreme adaptability? Here's another angle. If we can seriously consider surviving 6 months of darkness using technology and planning, what does that say about our ability to adapt to other impossible scenarios? Space colonization, for instance, or living on planets with completely different seasonal patterns. And there's a darker question lurking underneath all of this. If such extreme seasonal variations could trigger mass migrations and societal collapse, what does that tell us about the stability of our current civilization? How much of our social and economic systems depend on the predictable rhythm of seasons that we take completely for granted? The connection to real climate threats. Because here's the thing, while our planet's tilt isn't going to suddenly change, we are heading toward a world of more extreme weather patterns. Climate scientists are already documenting longer droughts, more intense storms, and shifting seasonal patterns that could disrupt agriculture and force mass movements of people. In a way, this extreme winter scenario is just a dramatic version of challenges we're already starting to face. And maybe, just maybe, thinking through these impossible scenarios helps us prepare for the very real changes coming our way. The wonder of ordinary miracles. So as we approach this year's winter solstice, maybe take a moment to appreciate the cosmic dance that makes our mild winters possible. That 23.5-degree tilt isn't just a random astronomical fact, it's the reason you can walk outside in Sydney in July wearing just a jacket instead of full Arctic survival gear. And the next time someone complains about how dark it gets during winter, maybe remind them, it could be 6 months of darkness. It could be a world where the sun literally disappears for half the year, where survival means migrating with the seasons or hiding underground with artificial lights and greenhouse farms. Instead, we get to experience the gentle rhythm of shorter days and longer nights, the subtle beauty of low-angled winter sunlight, and the promise that every day after the solstice brings us incrementally closer to spring. But that raises one last question I'll leave you with. If you had to choose between our mild, predictable seasons and a world of dramatic extremes, 6 months of blazing summer followed by 6 months of winter darkness, which would you pick? And what would that choice say about human nature and our relationship with the natural world? Let me know in the comments what you think. Would you take the challenge of extreme seasons, or are you grateful for Earth's cosmic moderation?